general nonlinear equation, how can we solve them? We can use a numerical function fsolve to solve a function given in a certain form like this. So this one. Y equals to, fx equals to 0. This is a general form of the nonlinear equation set. And x is a vector and f is also a vector. They are of the same size. To solve this equation, we have to denote the left-hand side of the equation by another variable y. So we will consider y equals to fx and find the solution of the y. So now I will say something about the procedures in the solution of numerical algebraic equations, and then I will use examples to demonstrate how to solve this kind of solution. So how can we solve this kind of equations? The first step is to select the variables to change the original equation in this standard format. For instance, if we want to solve this kind of equation, what we need to do is to select the two variables. We cannot say that there are two variables and x and y. We cannot do that. We have to assume that xy equals to x and x2 equals to y, so that we can have an x vector here. This is the first step. For any equation, we have to specify an x vector there. The first step, and selecting the x vector, we can rewrite the original equation into this format, and then to the matrix form like this. So this equals 0 should be somewhere outside the representation. So we should have a form like this. So only this part. We have a form like this. This is the first step, to write the standard form of y equals to fx. This is the first step. And the second step is to describe the equations. And there are three ways to describe the equation. One is by AND function. The other one is anonymous function, as you demonstrate this part by examples. And third one is so-called inline function, and I'm not going to recommend this kind of representation because this one is kind of old-fashioned and it is very, very slow. So I will concentrate on the first two kind of description to the original function or original equation, and this is the second step. And the third step is to call a function called fsolve. Third step, and then we should verify the solutions. To substitute the solution back to the original function and see whether the error is acceptable or not. So we have to follow these four steps to solve the algebraic equations. And these kinds of solutions can be used to solve nonlinear equations of any complexity. So we can solve nonlinear equations in this way. So let's consider again the example here. The first step is to select the variables and change the original equation in this format. And now we have to write the function to describe the relationship between y and x. So there are two ways. One is by the AND function. We have y as the return variable and the function name here, and x is the independent variable in the original equation. And we know that y should be a column vector containing two rows. Y should be something like this. And you can check this part with the original expression And we can easily extract the original equation in this way. And this is one way to describe the original equation. The other way is by anonymous function. And these two are quite similar. You see, in this one we have to create a .m file. And in this one we do not have to create a .m file. I said that these two methods are similar because we can use the x sign here, which means anonymous. We do not have to write a function or a .m file. And then bracket x, which should be exactly the same as this part. And then this is the content of the function. And the rest of it are exactly the same as this part. So we can use either of the two ways to describe the original equation. And this one are similar to this one, but I do not recommend this part. Just ignore it. We can use these two ways to describe the original equation. And the efficiency of the second one, the anonymous function, is much higher than the .m file. So, if possible, I recommend you to use this form to describe the original function. And there are limitations here. I will explain later.
It goes also in an M5? Or
yes. You can use this one, .m file, grade one.
Yeah, or in this one.
But this one, no, you just tag it under the prompt. You can dynamically define the equation. And it seems that this one is more useful than that one. And you can use f here to describe the equation itself. So just tag that in. The code is slightly different from the one there, but it should be the same. We can use f later to describe the equation itself. So this is the second step, to extract the original equation. And now let's come to the third step, to solve the equation. To solve the equation, we need to call a function called solve, where you have to specify the original equation here. And in our example here, we have to use f. And then we have to specify an initial searching point, x, 0. And I will concentrate on this part later on. We can select a searching point. I think you have already learned something like numerical analysis. To solve an equation with one variable, for instance, we have an equation like this, we can find the initial point somewhere here, and then we can use to find a tangent line and find another point here, and recursively find the solution.
Just like interacts on the line or something like that.
Something like I think Newton interactive method. Something like that. But in Matlab we used even more advanced method. I think it uses simplex method of optimization. So you have to specify a searching point, initial searching point. So this is a